Hello, this is lesson 1.3 with solving equations with a variable on both sides. All right, so our I can statement today is I can write and solve equations with a variable on both sides to solve problems. And I'm going to go ahead and apologize for my voice. I am sick, which is why I'm not present, but yeah, don't mind me too much. All right, so our new vocab, I need you to write this in your workbook. So write in your workbook. Write it on the sides if you can. Your new vocabulary word is identity. That's an equation that's true for all values of the variables. It's called an identity. Another term for identity is infinitely many solutions. Okay? And our essential question for the day is how do you create equations with a variable on both sides and use them to solve problems? All right, so let's go ahead and get started. And I did not want to use that. Okay. Got it. All right, moving on. So we're going to get started with our lesson with the explore and reason. So some friends want to see a movie that's showing at two different theaters in town. They plan to share 3 tubs of popcorn during the movie. So we're already told two different things, or we're already told some important information. They plan to share 3 tubs of popcorn during the movie. Well, this amount that they're giving us is the amount for 1 tub of popcorn. Okay, so we need to find the amount for 3. Okay, so let's go ahead and do that. We can set up a table or create a table. That's what I would suggest doing. You have space in your workbook, so you're good. And in your workbook, this is actually page 17. Okay, so go ahead and head there so you can follow along with me. All right, so go ahead and set up a table for part A, which asks us which movie theater should the friends choose and explain. So we need to know the total cost of all these first. All right, so what I'm going to do is I'm going to go ahead and have, I'm going to act like I'm only doing part A right now because you have space on yours. So you're just going to draw what I draw now or write what I write. Okay, so I know I have theater A versus theater B. And what's going into my comparison, how I'm actually going to accurately compare them, is the total cost, right? I need to know the total cost at both so I can choose which one I'm going to, or these friends are going to go to. All right, and what's going into the total cost is our popcorn and the number of tickets or the ticket price. Okay? All right, and now we've got what we need. Okay? All right, so theater A, we know theater A charges $5.75. They charge $5.75 for 1 bucket of popcorn. But we were told that some friends are going and they plan to share 3 tubs of popcorn. Okay, so we know, if we know what 1 is, we find what 3 is just by multiplying that amount by 3. And we do that for theater B as well. Okay, so we're going to go ahead and do that. And I'm going to actually write that in that color so you can see it. So times 3 and times 3. And that's going to get me my total amount. Okay, so I'm going to do 575 times 3. All right, so I get 1725 for theater A. And then I'll get 625 times 3. Sorry, 675 times 3. And that's going to give me $20.25 for theater B. All right, so we know for a fact what the popcorn's going to cost us at both theaters. Well, then I can't find the total cost of either of these theaters unless I know how many people are going to be coming to this movies or to the movie meetup, right? So that's something we're going to have to assume. So put this on your paper that you must assume the amount of friends going to the movies, right? All right, and let's just say we've got three. Let's say we're going to choose the amount for three people going, okay? So if that's the case, then I'm going to do the same thing that I did. I'm going to multiply the ticket prices by 3 in order to figure out how much I'm going to be paying for the tickets for those three people. All right, so theater B, 13 times 3 is the easier one for me. I know that's going to be $39. And then the other 1450 times 3. That's going to be $43.50. Okay? All right, and then we have this information. So now we actually have something to add, right, to find our total cost. Because to find the total of anything, you're just going to add them together, right? You're combining those terms. All right, so we're going to go ahead and add those exactly like we just said. So we're just going to go ahead and add them to find our total cost. Okay, so add them. And I'm going to have $60.75 for theater A if 3 people are coming. And for theater B, I'm going to have $59.25. So with this in mind, if I was trying to figure out which theater that the kids should go to, I would definitely choose theater B because it's the cheaper price, the cheaper overall cost. Okay, that's what I would say. So write that in words on your paper. So theater B, oh, I spelled it wrong. Is where the friends should go because it's cheaper for 3 people here. Okay? All right, so that is part A. And of course, you can pause the video if you need to go ahead and write this down. I'm going to go ahead and move along. So I'm going to just take this off here. Okay. All right. So moving on. So I know I've got all my information that I can look back at. Sorry about that. All right, got all this information. I've already answered part A, so I'm done with that one, right? And just to make sure you remember, we chose theater B because we had 3 friends. All right. So for what part B, for what situation would the total cost at each theater be exactly the same? So we want to know when the cost is going to be exactly the same. If it's exactly the same, that means that the cost should be equal. Okay, so this is the next part that you have actual space on yours. So I'm going to cross out part C on my paper so I actually have space as well. All right, I want to know when theater A is equal to theater B. Okay, and it's just like what we did in part A, right, where we set up that table, but instead of setting up a table, we're just setting up the equation. All right, so we're talking about really the total cost for theater A versus the total cost for theater B. Oops. Okay, got it. All right. So with that in mind, we can go ahead and talk about this. So we know for a fact that both of these theaters are going to be charging for popcorn. And I'm going to use a different color here. Sorry about that because it's getting a little confusing. Okay. So both of them are going to be charging for popcorn. And they're going to be charging for tickets. Okay. So what do we know about this? Well, we know for a fact it's just like the original thing told us, right? We're going to share 3 tubs of popcorn, right? So we already know from part A how much the popcorn was going to cost. It was $17.25 at theater A because that was times 3. And it was $20.25 at theater B. So I can go ahead and plug those in for my popcorn amounts. So I've got $17.25 plus something for theater A, and I've got $20.25 for theater B for the popcorn. And then I've got the number of tickets, right? So for tickets, I have 2 things. I've got the amount of the tickets, and I've got the number, like the actual like cost of the tickets and the number of tickets you actually are buying. So they don't tell us the amount of tickets that we're buying. So the amount of tickets is unknown. So write that on your paper. That's important to us, to know that the amount of tickets is unknown. All right, and when we have an unknown value, we're going to assign it a letter, right, a variable. Okay, so let's call tickets. Let's make it easy on ourselves, and let's call it T. Okay, so how much, so we know we've got T, some kind of amount of tickets, and now we just need to go ahead and assign the value for each ticket and apply it to each theater. So theater A costs $14.50, while theater B costs $13. Okay, and now we have set up our equation. Yes, so then all we have to do is go ahead and answer it now. All right, and I'm going to go ahead and erase this here. So if you need to write this down, go ahead and pause this video so you can get this down. But I'm going to erase it so I can have like some more space to actually solve. All right. Oh, you know what? I want this part to stay. Okay. Okay, so let's go ahead and solve our equation. All right, so the first thing that you can do is go ahead and draw your little T-chart. So you know you have that, and you can go ahead and start moving things around. So you need to make sure that you understand that it really doesn't matter which term you move as long as you keep the equation balanced. That's something we talked about earlier this week, where the order of that you're moving these terms does not matter, but keeping that equation balanced by using the properties of equality is what's really gonna make sure that you're answering these questions correctly. All right, so I'm gonna first move my decimals or my constants. So I'm gonna move them together. I'm gonna move the 1725 over to the right side. And in order to move it, I'm always moving the opposite. Okay? All right, so when I do that, I'm gonna cross out what cancels, and I'm gonna drop down what I have not touched. All right, so I've got 1450T is going to equal $3 plus 13T. My next step is to go ahead and move that 13T over with the 1450T. So I'm going to do the opposite of that. What the opposite of plus is minus. So I'm going to minus 13T on both sides. And remember that 13 was $13. So you can just do that if that makes you feel better. All right, so I know that the 13s are going to cancel, the 13t, and I'm going to drop down that 3 and simplify. So I've got $1.50 t is going to equal 3. And my very final step is to divide both sides by $1.50. And I'll find that t equals 2. So the final thing you need to do is make sure you've actually answered the question. The question for part B said, for what situation would the total cost at each theater be exactly the same? I know it's going to be the same when t equals 2. And if you recall here, we said that t is the amount of tickets. Okay? So the cost will be the same when the amount of tickets is 2. Right? So go ahead and put that on your paper. The cost is the same when the friends buy 2 tickets. Okay? All right. So then part C, that final part there, it says there are different methods to solving this problem. Which do you think is best and why? So this is all a personal question for part C. Did you like setting up, so this is really just saying, did you like setting up a table and solving it that way? Or did you like setting up an equation and then solving for your variable and just interpreting there? So you need to put on your paper, just write a 1 or 2 sentences of which one you prefer, the table or the equation, and why. All right, and then we're going to go ahead and move on to our next part, which is example 1 here. All right, so example 1, I'm actually not going to go over the example. I'm just going to go over the try it with you. The examples are almost exactly like this, so I just feel like we can talk through these, especially since I'm not there. All right, so we have 2 try problems, parts A and parts B. All right, so I'm going to go ahead and cross out part B right now because you have a little bit of space. Just kind of divide your paper up. All right. Okay. And this study tip should actually just say it doesn't matter what order you use. So just kind of ignore that. All right. Order doesn't matter when you're solving an equation as long as you keep the equation balanced. So put your answer on there. All right. Or I'm sorry, put that on there. A study tip. Order doesn't matter when solving equations. Just remember, and just write this somewhere on your paper, to keep the equation balanced. Okay? All right, so let's answer part A. So the first thing I would do in part A is I would go ahead and distribute my numbers that are outside of my parentheses to the terms inside the parentheses. Okay, and if you notice, I've drawn 4 arrows, which means I have to multiply 4 times. Okay, so that gives me a visual reminder that I actually have something that I need to be doing, and I have to do it 4 times. Okay, so I first got 100 times z, which is 100z. Then I've got 100 times negative 0.2, which is negative 20. Then I've got negative 10 times 5z, which is negative 50z. And I've got negative 10 times 0.8, which is negative 8. All right, I'm going to set up my little chart or my line so I can go ahead and answer my equation. All right, so the first thing I would do here is I'm going to go ahead and combine my variable terms. I'm going to move those to the left. So I'm going to add a 50z to both sides, and I make sure I match them up. So I put my z underneath my z term underneath my z term. I don't want to confuse myself by putting it under the 20 because I might, have a brain fart and just kind of, put them together, and I don't want to do that. All right, so I'm going to add 50z to both sides. All right, I'm going to cross out what doesn't or was canceled out and drop down what I have not touched and simplify. So I've got 150z here minus 20 is equal to negative 8. My next step is to add 20 to both sides. All right, and cross out what I know is canceled, drop down what I've not touched, and drop down that 150z is going to equal 12. My final step is to divide both sides by my coefficient, which is 150 here. And if you look here, this is kind of like a way to check yourself to make sure you're on the right track. When you divide 12 by 150 using your calculator, you should get a really small number because I'm dividing a small number by a big number, right? So you shouldn't get a whole number there. Okay, so make sure you're not swapping the order of that. Do 12, actually in your calculator, do 12 divided by 150 and you will get your answer. Okay, so our answer here is z equals 0.08. Okay, and that's my final answer here. Always box or circle your final answer when you're solving an equation. All right, so that is it for part A. Okay, moving along to part B. And I'm just going to erase this. So if you need this, just go ahead and pause this video here. Okay. All right, so we're ready for part B. Part B, I've got a fraction now. All right, so I would go ahead and say this. If you don't like to deal with fractions, you can just go ahead and change your fraction to a decimal. So change 5/8 to a decimal. And all you have to do is do 5 divided by 8 in your calculator, and you're going to get 0.625. And again, this is a personal preference. If you don't like to deal with fractions, go ahead and change it to a decimal and keep it moving. All right, so let's rewrite. So I've got 0.625 multiplied by 16d plus 24 equals 6 times d minus 1 plus 1. All right, and now I can go ahead and start answering. Okay, so I'm going to go ahead and distribute that decimal on the left and distribute my 6 on the right. Okay, so I'm going to go ahead and do my multiplying. So I've got 0.625 times 16d, and that's going to give me 10d plus 0.625 times 24 is 15. So I've got a really simple one now, and it looked like it was crazy at first, but it's not, so it's nice. Okay, and I'm gonna draw that. Okay, and then on the right side I've got 6 times d, which is 6d, and on the left, I'm sorry, and then I continue and I have 6 times -1, -6, and I'm also going to drop down that +1. Don't forget that that was there. All right, before I start moving things around, I'm going to combine like terms on the right side by combining that -6 and the +1. So that's like saying I owe somebody $6. I pay them back 1. Now I only owe them 5. Okay, so I owe them 5, and there we are. So I've got 60 minus 5 is equal to 10d plus 15. Right now I can move things around. So I would go ahead and I'd move my 6d over to my 10d. Cross out what I know has canceled and drop down what I've not touched. All right, so I've got plus 15 and a -5 now over there. And I've got a 4d here. All right, next I would move the 15 to the -5. And I've got 4d. Cancel those out real quick. All right, 4d is equal to -20. And I'm going to just draw a little arrow over here so you can see. So I have 4d equals -20. Sorry about that. And finally, I'm going to go ahead and divide both sides by my coefficient, which is 4. Okay, so D is going to equal -5. And that's my answer there. All right, so there is your try number 1. And we're going to go ahead and move along. Okay. All right, number 2. Solve each equation is the equation in identity. Remember, we talked about that in the beginning. In identity is just the same thing as infinitely many solutions. Okay? All right, so let's go ahead and solve these. All right, so part A, I'm actually just gonna, part A is here. So I've got the t minus 27 equals that. All right, so the first thing I want you to know is when you have something that looks like this and you have that negative attached to the parentheses here, just look at that -1 as the negative as an invisible -1, right? Because that's what it always is whenever you have multiplying and you can't actually see anything. So if I have like an x, I know that x is actually equal to 1x, right? So if I've got a negative parentheses, it's actually equal to a -1 times that parentheses, okay? Times whatever's in the parentheses. All right, so let's go ahead and rewrite this. All right, so I want to rewrite. So I have t minus 27 is going to equal -1 times 27 minus t. Okay, and then I'm going to go ahead and distribute so I can start solving. So I'll distribute the -1 to both terms inside the parentheses, and I'll drop down what I have not touched. So I've got t minus 27 is equal to -27 plus t. And again, I had a -1 and a negative t. Gave me a positive t. All right, so I know for a fact that I can rewrite the right side. I can put my variable term first because I'm using addition, so I can change the order. So I can go ahead and do that to make it a little easier for us to see. So I'll just say I'll have a positive t and a -27. Yes, I still got that. That's still equal. And I'm just going to bring down the other side. And you notice that the left side matches exactly to the right side. That is what we call the identity. Okay? We've got an identity here, which is, of course, infinitely many solutions. Okay? Great. All right. And I'm going to go ahead and do part B on the other side. So part B, we had 16 times 4 minus 3m equals 96 times -m over 2 plus 1. Okay. So when we're solving this, we're going to go ahead and distribute our 16 on the left and our 96 on the right side. All right, so we're going to have 64 minus 48m equals, and when I'm doing this 96 here, I'm going to go ahead and erase this just so you can see this. No. Okay. All right, when I'm doing 96 times -m over 2, obviously the m over 2 is a fraction, right? I can make my 96 a fraction as well and just multiply like normal. So I'm going to multiply straight across, okay? Because that's how you're actually multiplying fractions, straight across. Okay, so I've got -96m over 1 times 2, which is 2. And if I can do that, I can go ahead and combine these so I can do my division, and I would actually have -48m. Okay, so I wanted you to see where that's coming from, so I'm not just writing something random and you didn't know what it was. Okay, so I've got -48m, and then of course I still had my 96 times 1, which is plus 96. All right, so we can go ahead and continue solving. So I had to go ahead and move both of my variable terms to the same side. I just go ahead and add 48m to both sides. And you see that something's happened, right? Well, what's happened is the variable terms are gone now. And I'm only left with these constants that don't match. I've got 64, and this says it equals 96. That is not true. Oh, that looks crazy. That is not true. Okay, when you have a statement that looks like that at the end of your solving, then what you're going to say is if you have a false statement like that, then that is no solution. Okay, and then you should be able to generalize that whenever you see something that's like this is a really good example of this. When you see something like this where they have the exact same variable term, we had a negative 48 here, but they had different constants. Okay, they don't match. When that happens, I'm going to have no solution. Okay, so put that on your paper, that no solution is going to give me the same variable term but different constants. Okay, and that is it for number 2. All right, moving along. All right. Okay, so moving on. Try number 3. We have how many pounds of Arabic, I know I said that wrong, Arabica coffee should you mix with 5 pounds of Robusta coffee to make a coffee blend that costs $12 per pound? So I want you to draw out this table on your paper. All right, and then we're going to answer it. We're going to fill it in together. So you can pause the video if you need to go ahead and draw out your table. All right, so let's break it down like this. Again, I really love when we can use tables in math because it's a really good visual representation and it just helps me organize my thoughts super easily. All right, so let's write down what we know from this problem. I also put on here, I know this isn't on your paper, but this is an important piece of information that we needed, that the Arabica coffee costs $28 per pound. So that's going to go right here, right? That's the price per pound right here. Okay, so that's going to go right there. It costs $28 per pound. And the Robusta coffee costs $8.75 or $8.75 per pound. Okay, they also tell us more things. They tell us that they want us to mix the Arabica coffee with 5 pounds of the Robusta. Okay, so they tell us the exact amount of Robusta to use. And they also say that here, between the price and the amount, we're multiplying. So I know that I'm going to be multiplying here. Okay? And I've got all this good stuff equals. Okay? So I know for a fact I can fill in this second row, the total cost, because all I have to do is multiply. So I'm going to go ahead and do that. Let's fill in that part of our table. Use your calculator. So we got 875 times 5, and that is 43.75 for the Robusta coffee. All right, they did not tell us how many pounds of Arabica coffee we're needing to use, right? So if they didn't tell us, which of course that's why we're solving for it, it's an unknown amount. So let's make the unknown amount be our variable, right? This is our unknown. Oh, that's not our unknown. This amount is our unknown, okay? So we're going to call it A, all right, for the pounds of Arabica tea. All right, and we know, again, we're going to be multiplying across. So we've got 28 times A, which is going to give us 28A. All right. And then they said the coffee blend is going to cost $12 per pound. Well, price per pound goes here, yes? So let's go ahead and write it there. So we've got $12 there. And of course, if it's a blend of things, we need to go ahead and do our totals. If it's a blend of both the Arabica and the Robusta, it's the amounts that were there, right? Well, the amounts that we have here are A and 5. So they should go together. We should have A plus 5 in our amounts for the coffee blend because we have both Arabica and Robusta. And when we multiply them together to get our total cost here, we're going to just have 12 times A plus 5. Okay, so this one was like, okay, so we got it all into our table, so it's organized. Now let's go ahead and make an equation to solve for this. Okay, because we really need to solve for that A value. Okay, so what we're actually doing is we're trying to see where we have the cost of the Arabica and the Robusta. Yeah. So we're going to have the Arabica plus the Robusta, and these are all total costs. Okay, is going to equal the coffee blend. Okay, because we're using amounts of that, right? So that's good. All right, so let's go ahead and do that. We know the total cost of all of them because we wrote that in a whole column over there. Let's go ahead and put them in their place. So we know the Arabica coffee is 28 A for the total cost. So that should go right here at Arabica. All right, so I've got 28, and I'll write this in a different color. 28A, okay? And then I've got plus the Robusta coffee is here. So Robusta, the total cost is $43.75, and it should go here. All right, so I've got plus 43, plus 43.75. And finally, we've got the coffee blend. The total cost is this. I've got 12 times A plus 5. Okay? And finally, all I have to do now is answer my equation. So it took a little bit of work for us to get there, but now we know how to solve this for sure. All right, so let's go ahead and solve. So the first thing I would do is distribute, and I know you guys will do the same. So we'll have, I'll just keep it there. We'll have 12A plus 60 is equal to 28A plus 43.75. The next thing I would do is go ahead and move my variable terms to the left by subtracting 12A on both sides. Okay, it's going to cancel out on the right side, and I'm going to drop down my 43.75 and my 60. All right, and then 28A minus 12A is 16A. Next, I'm going to subtract 43.75 from both sides. Okay, it's gone there, and I'm dropping down my 16A. And I'm just going to subtract there. So I've got this. All right, I got 16.25 left, and my final step is going to be to divide both sides by 16. So I find that A is going to be equal to 1 point something. Let me get my calculator real quick. So I've got my 16.25 divided by 16 is $1.02. Or, sorry, 1.02. And remember that A didn't stand for dollars because I just said stuff. My bad. A actually stood for our unknown amount. Yes, our unknown amount, which is there. And it was the unknown amount of the Arabica coffee. Okay, so then you can go ahead and write this on your paper. We can fill that in. All right, so we must mix 1.02 pounds of Arabica coffee with the 5 pounds that was given to us of the Robusta coffee to make a blend that costs $12 per pound. It just looks dumb, but $12 per pound. And there was that answer. All right, so I will pause the video here to make sure that you've got everything you need for this problem, and we're going to move on. Okay, so our final try it for today. Again, the example was very similar, almost exactly the same thing. They just changed like the joining fee and the amount per song. So we're not going to do that one. We're just going to do this together. All right. So Cameron's friends Cameron's friend tells him of another service that has a $15 joining fee, but charges $80 per song. At what number of songs does this new service become a less expensive option than Cameron's current service? All right, so first off, in order to figure out, because you're really trying to compare the two, right? In order to compare the two, you need to see when they're actually equal, all right? And then we'll figure out the next steps after that. So step one, maybe don't write like that. Step one is to find when the current plan equals the new plan. Okay, so that's our first step. And maybe write a little smaller than I am because you don't have that much space on your paper. All right, so the current plan for Cameron is he's got this $95 or 95 cents per song, right? The per means I need to be multiplying, right? That's a multiplier language, okay? And then per song, we don't know how many songs, right? So how about we say song is S, okay? So song is S because it's an unknown, right? Unknown amount. Okay, so his current plan is 95 cents per song. This new plan is 80 cents per song, but it's also got $15 to join. So he's also, which is plus, got to pay that $15 to join. Now let's go ahead and answer that. All right, so let's combine our terms by moving that S term to the left side. So we'll subtract 0.80 S on both sides. And we've got 0.15 S is equal to $15. Okay? I'll just here. All right, and our final step is to divide both sides by 0.15, which is our coefficient. And we've got that S equals 100. All right, and remember S is our number of songs. So they're equal. So the two plans, well, let's say they cost the same. The two plans cost the same. At 100 songs. Okay, but we want to know is when should he change to this new plan, right? After how many songs, right? Because we want it to be less expensive. So I'm going to go ahead and erase this and move to our step 2, which is the final step. We know 100 is the equivalent point, right? That's when they're equal to each other. Okay. So step 2 is to find when the new plan is less than the current. All right, and remember, we had our equation, which was 0.95 s equals 0.80 s plus 15, right? We knew that they were equivalent at 100 songs. So how about we just choose a number of songs that's either above or below 100 in order to figure out when the new plan is going to be more or less, right? So let's go ahead and do that. So we've got the new plan and the old plan, right? Let's break them up and let's figure out what it's going to be. And let's just choose it when S is 101 songs, right? So this is when we got more than the equal amount. Yes? Okay. So I'm going to kind of break these up to make it easier on myself and on you as well. Okay, good. All right, and we've got our current plan here. All right, so just plug in your value for S, which is our number of songs, into both of these expressions in order to figure out what the answer is going to be. Okay, so let's figure out which one's less. All right, so we've got 0.95 times 101, and over on the right we've got 0.80 times 101, but don't forget to add on that 15. All right, when you do 0.95 times 101, you get $95.95. And over to the right with a new plan, when you do 101 times the 80 cents and plus your 15, you get $95.80. Okay, so we can see when it's a number of, we can obviously see now that the new plan is cheaper here. And what made this special is that the amount that we chose was over the amount that they're equal at, right? So that means that any amount of songs that he, or anything over 100 is when he's going to need to go ahead and switch to that new plan. Okay, so this is a really good real world problem, even though it doesn't make much sense just because who's paying 95 cents per song? It's kind of crazy, but because that it added up. All right, but this is a really good way to answer this question. All right, and of course there were definitely other ways that you could have answered this, but I'm doing what I can think of at this point. And remember that your ideas are amazing and I love to hear them. All right, so since we had a cheaper option here, we know that Cameron should switch to the new plan when he wants more than 100 songs, which I feel like anybody wants that. So just saying. All right. So that's good. That is number 4. And that should be it. All right. Yes. All right. So here it is. If you needed to write this down, I would go ahead and pause this. Make sure you guys got this. And I'm going to move on. All right. Concept summary. So go ahead and we're just closing out today. So this is what we learned today. Solving equations with a variable on both sides. Linear equations can be used to solve mathematical and real-world problems, which we saw. So in words, this means that you can use properties of equality, which we learned earlier this week, to solve an equation with variables on both sides. Equations can have one solution, which is, it looks like something like this, where we have x equals some type of number. It could be like 3 or literally anything else, right? It could be infinitely many. And this looks like I could have like 3x equals 3x or 5 equals 5 or something like that, right? Where the left side equals the right side. And we also called the infinitely many solutions could be called identity. And we also learned that equations can have no solution, where I end up with a false statement, right? So it could say that 6 equals 9, but that's clearly not true, right? That's what gives us the no solution. Okay, so in numbers, it looks like this. So I did all that, but again, this is really just an easy way to look at that. All right. And then you guys are going ahead and moving on with your assignment for today. Make sure that you answer the do you understand questions and the do you know how. Okay, that's numbers 1 through 9. Go ahead and get to work on that, and then you have your practice problems. Just ask your teacher for those. All right, thank you.